Hey everyone, and welcome. Today, we are going to absolutely nail the chapter Our Life Supports. Now, I know this is a super important topic for your exams, so stick with me. And by the end of this session, you'll have every single concept down, crystal clear. Let's get you ready to ace those questions. So, here's our game plan. We're going to walk through these 6 key areas one by one. Think of it as our roadmap to mastering this chapter. It's all laid out logically so you can follow along and revise easily. Let's jump right in.
All right, first up, section 1, the introduction. We're going to start with the absolute basics here, laying the groundwork and figuring out why things like air are called life supports in the first place.
Okay, let's kick things off with a quick warm-up question right from your book. Which of these pollutes the air? You've got planting trees, burning firecrackers, and riding a bicycle. Yeah, it's a pretty easy one, right? Of course, it's burning firecrackers. The other two are actually great for the environment. A simple but important place to start.
Okay, now let's get into the real meat of the chapter. This section is super important because it builds the foundation for everything else we're going to talk about. We're starting with the very air that we breathe. So what exactly is the atmosphere? You need to know this definition by heart. It's the thick blanket of air that surrounds our planet, held in place by Earth's gravity. And listen, it has 3 critical jobs you have to remember. It keeps our planet's temperature just right, it shields us from the sun's nasty UV rays, and it acts like a bodyguard, burning up meteors. A classic 1-mark question right there. Now, this atmosphere isn't just one big blob, it's split into 5 different layers. Think of it like a giant 5-layer cake. At the bottom, we have the troposphere. That's where we live and where all the weather happens. Next up is the stratosphere, where planes cruise and the super important ozone layer lives. Then the mesosphere, where meteors go poofed. Above that, the thermosphere is where satellites hang out, and way, way out is the exosphere, which just fades into space. This table is gold for match the following question, so pay close attention. Okay, check out this chart. It's a super important visual that shows you exactly what's in the air we breathe. You have to burn these numbers into your brain for objective questions. It's mostly nitrogen, a whopping 78%. Then comes oxygen at 21%. And everything else, all the other gases combined, make up just a tiny 1%. Remember those numbers, 78, 21, 1. So what do all these gases actually do for us? Well, nitrogen is essential for making proteins, which we get from plants. Oxygen, well, you're using it right now to breathe, and it's also needed for anything to burn. Carbon dioxide is basically food for plants. They use it for photosynthesis. Even those other tiny gases have jobs. Argon and light bulbs, helium and party balloons. And that water vapor? That's what makes the air feel humid. See? Everything has a purpose. Let's move on to section 3. This is the really cool science in action part of the chapter. We're going to prove some of the amazing properties of air, this invisible stuff that's all around us. First property, air takes up space. How do we prove it? Super simple. Take a flat football, start pumping air into it. What happens? It gets bigger, right? That's because the air is filling up all the empty space inside. Now, for your exam answers, this is crucial. You must write these 4 points: aim, materials, procedure, and conclusion. That's how you get full marks. Second property, air has weight. Sounds a bit weird, but we can prove it. Imagine you've got 2 blown-up balloons balanced perfectly on a ruler. Now, what happens if you pop one? The side with the full balloon will immediately drop down. Boom. That's your proof that the air inside it actually has weight. And again, remember that 4-part structure for your answer. So let's connect the dots. If air has weight, it must be pushing down on everything, right? And that push, that force, is what we call pressure. You see this principle in action all the time with things like ink droppers or the syringes a doctor uses. They work because of air pressure. And here's the really cool part. Air doesn't just push down, it pushes in all directions. The classic experiment with a glass of water and a piece of cardboard shows it pushes up. Blowing through a straw into a sealed bottle shows it pushes down. And watching a plastic bottle get crushed when it cools proves that air pressure is pushing from all sides at once. This could definitely be a 5-mark question, so make sure you understand these 3 examples. Okay, we've talked a lot about air. Now let's switch gears and talk about our planet's other critical life support system, water. You know, the stuff that covers about 71% of the Earth. Let's dive into why it's so vital. So, water isn't always perfectly pure. It can have 2 main types of impurities. First, you have soluble impurities, like salt. These dissolve completely in the water, so you can't see them. Then you have insoluble impurities. Think of sand or mud. These don't mix in and you can definitely see them. Plus, there are germs. Knowing this difference is the key to understanding how we clean water.
Okay, so we know water can have all this stuff in it. The next big question is, how do we get it out? This section is all about the methods we use to purify water and make it safe. Let's get into it. For getting rid of the stuff you can see, the insoluble impurities, we use a 3-step cleanup. First up is sedimentation. You just let the water sit, and all the heavy stuff like mud sinks to the bottom. Simple. Next is decantation, where you gently pour the clear water off the top, leaving the gunk behind. Finally, for any tiny bits still floating around, you use filtration. Now for the tricky part, getting rid of the impurities you can't see. For this, we use evaporation. You heat the water until it turns into vapor and it leaves all the dissolved stuff behind. Then you cool that pure water vapor down so it turns back into liquid. That's condensation. And when you do those 2 steps together, evaporation followed by condensation, the whole process is called distillation.
Okay, pay close attention here. This is a very common long answer question. The water that comes to your house goes through a big official 5-step process. Coagulation, flocculation, sedimentation, filtration, and the final killer step, chlorination, which kills all the germs. You have to memorize these 5 steps and, more importantly, their correct order.
And what about at home? Well, thankfully, it's a lot simpler. The number 1 easiest method is just boiling the water. It's a great way to kill most germs. Or, of course, you can use the modern water purifiers and filters that many of us have. Both are great options.
All right, you've made it to the final section. It's time for our exam-ready review. We're going to do a rapid-fire round to lock in everything we've just learned. After this, you'll be 100% ready for any question on this chapter. Let's go. Let's do a quick-fire round of key definitions. Atmosphere, the thick blanket of air. Humidity, the amount of water vapor in the air. Pressure, the force that an object presses with. And condensation, when vapor turns back into liquid. Nailing these definitions gets you easy marks. Okay, time for a pop quiz. First, MCQs. Where's the ozone layer? In the stratosphere, correct. How do you remove soluble impurities? Through distillation. What does water vapor in the air make it? Humid. And the last step in water treatment? Chlorination. Awesome. Now for true or false. Planes fly in the stratosphere? That's true. Air exerts pressure in all directions. Also true. We cannot use oxygen directly from the air? That's false, of course we do. And finally, distilled water is not fit for drinking. That's true because it lacks important minerals. Great job!
And here we are, the final challenge. Let's see what you've got. Question 1. Which layer is for satellites? The thermosphere. Question 2. Which gas protects us from UV rays? That's ozone. Question 3. What are insoluble impurities? They're the things that don't mix in water, like sand and mud. And last one, how can you make water safe at home? By boiling it or using a purifier. And with that, you are officially an expert on this chapter. Thanks for joining this explainer.